Okay, so the first topic we're going to discuss is one-sided limits, which I guess is really probably technically the only thing we're going to discuss today, but one-sided limits. Okay? So, we've been talking about evaluating a limit as x approaches 2, and we've been talking about what is it approaching from both sides. Now we have a way to describe both sides. Okay? So you see how this has the limit as x approaches 2 with a negative superscript? That means what is the limit from just the left side? Okay, can you see that negative superscript? And then the limit as x approaches 2 with a little positive sign for a superscript. That means we're looking at the right side only. Not really. I mean, what we're really going to look at is piecewise function. Okay? Okay, so basic examples here. Okay, so this is the limit as x approaches 1 from the negative side, so from the left, of 4x squared minus 5. Okay, let's think about what's going on graphically. What is 4x squared minus 5?
It's parabola. That's
Shifted and vertically stretched. Like this, right?
Yes.
Okay. So the limit as we approach 1 from the left side would be what?
Somewhere close to 1.
Negative 1. Because this point is 1, negative 1, right? Okay. So right now, okay, taking the left-handed limit on this isn't really any different than taking the limit, right? But right now we're just looking at only from the left side, okay? This is interesting. The limit as x approaches negative 2 from the right side of the square root of 4 minus x squared. What does this graph look like?
It's a
I don't know.
It's
Like the square root of 4 minus x squared is.
Put it in a calculator if you don't know what it is.
That's the difference of squares right there.
Plus or minus.
So that doesn't do any good for us.
Isn't it just a stretched vertically?
No, because we have this x squared.
It's reflected over the y.
What if we had y equals the square root of 4 minus x squared? How would you solve this?
Square both sides.
But it is a side was parabola. I was right.
What is it?
It's a circle.
No.
It's
Darn it.
circle.
Which piece of the circle? The whole
Middle
circle?
part. Yes. No, because it equals 4 now.
Let's think about solving this backwards. If I had this and I went to here, and then I went to here, when we square root both sides, what do we typically have?
Positive or negative?
Okay, I only have the positive.
Hey.
Give us a my circle.
Wait, what? No, don't do
Okay, if I were to solve for y from here, I'd move the x squared over. I'd square root both sides. But when you square root both sides, you have the plus or minus.
Okay.
We only have the plus. So it's only the top half of the circle.
Okay.
So
Okay.
is there a way to get the right half instead of the
That would have to be a like x equals the square root of y minus x squared? It's not a function. Okay. So, now this is interesting, right? We want the limit as x approaches -2 from the right. Here's -2
Oh.
from the right. What are we approaching?
0.
0. Okay, what about from the left? We have nothing on the left. Okay, so here's an example of where we could only take a one-sided limit because we only have graph on the right side as opposed to the left side. Okay, what limit could we take approaching 2? We could only take the left-handed limit here. Okay, cool. So, I want you to look at this. Let's see. Let's look at these two first. What is the limit as x approaches -1 from the right side? 1. From the right side, we are approaching 1. What about from the left side? It approaches 2. Even though it's a hole, that's fine because we're approaching it. We're getting infinitely close to it. Okay? But what if I asked you the limit as x approaches -1? Why? Because the right hand limit and the left hand limit
Are not the same.
are not the same. Okay? What's the limit as x approaches 2 from the left side? From the left side of 2, we're approaching 2. What's the limit as x approaches 2 from the right side? So what's the limit as x... You don't even know what I'm going to ask you. Approaches 2. 2. If the right hand and left hand limit are the same, then that's what the limit is. Correct?
You say 3 at the bottom until it's not everybody else.
Huh? Okay.
Are you recording this also?
Okay. The limit as x approaches 1 from the right side.
3. No, 1.
From the right side is 1. Okay, good. You will have to identify limits based on a graph tomorrow. I'll tell you that right now. Regular limits, right hand, left hand, whatever. Okay? Okay, so just like we talked about in our picture, if I want the limit to exist, the right and the left hand limits need to be the same. So we said that the limit did not exist here as x approaches -1 because our right and our left hand limits were different. Okay? What kind of function is this? It's a piecewise function. Okay? Sometimes the pieces came together nicely for us and we could evaluate a limit. Sometimes they did not. So when you have a piecewise function, and I ask you to evaluate the limit where we have a break in the domain, what do you think I'm going to require of you?
Work.
What kind of work, though?
Graphing work.
The thing where you get closer and closer to the number.
Okay, let me go through this again. Sometimes our pieces overlapped, sometimes they did not. But what did we do? We looked at the left-hand limit, and we looked at the right-hand limit.
You're gonna make us look at the left and the right hand limit.
Good job.
Yay.
Okay, so in order to evaluate this, now this would not matter if this was x approaches 2. But since it's x approaches 0, that's where the break in our domain is. We have to look and we have to show our work for the right and left hand limit. Did you see how I said show your work? Okay. So the limit as x approaches 0 from the left side. Okay, which piece of the domain is the left side? This x plus 1. So all we have to do is put 0 in for x plus 1. And what do we get?
1.
The limit as x approaches 0 from the right side means that we're plugging 0 into this piece because this is the right side of 0. And that is,
1.
do our right and left hand limits equal each other?
Yeah.
Then that's what our limit is.
The y-intercept
Both the y-intercepts are the same and the both is 0.
Okay, I'm glad that you can recognize that right away. On tomorrow's quiz, I would like to see this work so I know which piece you plugged into. Okay, I know you can do it in your head. I know, but I would like to see it. On the AP test, where you're just choosing multiple choice answers, doesn't matter if you show work. For me, it does. Okay, let's look at the graph. What do we have? This is a line. This is a, and lucky enough for us, they meet up where their domains break. Okay. Look familiar?
Yeah. No.
Yes. We already know what?
that
The
they
answer.
don't have a limit.
We already know that this limit's not going to exist, right?
Yes.
Let's prove our answer by showing some work here.
Aw.
What's the limit as x approaches 5 from the left side?
-5.
0. Does not exist.
What does this graph look like? Show me with your hand. What does it look like?
Yeah.
Going like this, right? Or is it going like this? Which way?
This.
Like this?
Yeah. Yeah. But they're like,
And where? What are the heights of these?
5 and -5.
1 and -1.
1 and -1.
Bam. Goose, Jared.
Why? Because we either have negative x minus 5 over x minus 5 or positive x minus 5 over x minus 5, correct? Okay, didn't I? Okay, you had a, I just want to make sure. Okay, so that's why we have this at 1, this at -1. So what's the limit as x approaches 5 from the left? What's the limit as x approaches 5 from the right? Are those the same?
no.
No, so we already knew this, but our limit does not exist.
Yeah, 5.
So do we still need to try with that one? Even though we're reading something that gave us information. Said
On this particular one, when you have the square root of x over x, I will let you write those answers.
Yay.
Yes.
Piecewise function?
Okay.
Okay.
Holy moly.
Why do you say holy moly?
Because there's a hole.
Do you agree with Jared?
Yeah. Man. Sure, you were saying this.
Okay, where's our hole?
X minus 1.
What? X equals 1, right?
Yeah.
So what does our graph look like? Let's describe it. We have a with slope up, y-intercept up, our goal is at
Don't you wish you were recording this one?
I am. What's the limit as x approaches 1 of g of x?
2.
How could you get that without the graph?
You just follow the line.
All along, see where.
You have x plus 1.
Yeah.
You're evaluating the limit as x goes to 1.
You plug in the
So you
line.
plug in 1. Okay? Now, just to be redundant, okay, the limit as x approaches 1 from the left side is 2.
What am I doing?
The limit as x approaches 1 from the right side is
2.
You're attempting to do math.
And I think we kind of.
those are the same. So, okay. Now, is this work that I'm going to require of you right here?
I don't know, are you? Hopefully not.
No, you can cancel out the factors and then do direct substitution, but I want you just making all these connections here. Okay?
I see one connection.
I would like you to find this limit
So,
by showing your work. You need the limit as x approaches 1 from the left of f of x. Okay? That needs to be written. Equals, you're evaluating it, 1 cubed plus 1, which is 2. Okay? Without writing the limit, when you write limit, you have to have of something. Okay? That's what you were leaving off, correct?
Yeah.
Okay. Caleb.
You might have already said this, but why would you use the top equation if it does the x, well, 1 doesn't follow the other two?
Well, remember we're just looking at it from the left side. So even though there's not a value at 1, there's a hole there because we have values leading all the way up to it. And so we can find the limit of that hole. Right? Okay. And so then the limit as x approaches 1 from the right side of f of x, you need all of that, equals, then you can do your 1 plus 1 equals 2. Okay? Is everyone okay on that notation? This is the only thing that will get you full credit. If I see this, just the equals 2, you will not get credit. Okay? Does everybody understand? I'm doing this right now. I'm going to grade it. Okay. So, this is now your homework.
Oh, I already wrote it down.
fail,
Well, that's your homework, but not that. Okay.
not fail.
So, your homework, I'm going to give you a limits using graphs worksheet. And then on the back of it, you can just put the page 76, 7, 12, and 15 through 18.